All right, we're going to revisit a topic that we've talked about before, but get a little more in depth. We've talked about position, velocity, and acceleration, and you certainly know that the derivative of position, so if I have position that a lot of times they call s of t, you know that the derivative of position is velocity, and you know that the second derivative of position, or the first derivative of velocity, is equal to acceleration. That's what we've done before. And so in the problems that we've done before, we're always kind of taking the derivative. Well, now that we know integration, we can kind of go back the other way. In other words, let's look, if a car starts off from a dead stop, that's important, okay, with an acceleration of 10 feet per second squared. And really, I think yours has the word constant right here, because I need to kind of tell you that. So let's see here. That means that a of t is equal to 10. Now then, it says, what is the car's velocity after 10 seconds? Or the question might say, hey, what is the velocity at any time? And so you have to solve for velocity. Well, we know that, if we're going backwards in a sense, that the integral of acceleration is going to give you velocity. Now here's what's important if you go to solve this on a free response. You get 10t plus c. You have to put in that constant of integration. Now the fact that it's a dead stop, that means that the velocity at 0 is equal to 0, right? I mean, if he stops, then at t equals 0, he has no initial velocity. So even though, I mean, I get it, you're like, well, that's stupid, I have to show that. Yes, because every time that you integrate, you've got to make sure that you put that constant of acceleration in. So the velocity at any time is equal to 10t. Now, obviously, if the question says, what is the car velocity after 10 seconds, that means you're just going to find v of 10. You put that in, and you would get 100, and the units would be feet per second that you would need to write down because units were introduced. How far from the start is the car after 10 seconds? Well, that's asking for position. So now I'm going to just really do the same thing, kind of repeat the process. I know that position would be the integral of velocity. So I would get position at any time is going to be 5t squared plus c. And once again, the dead stop, well, if he hadn't gone anywhere, then his position at 0 is also 0. So in the same way, this c is also 0, and so for the position equation, I get s of t is 5t squared. And so what is the position at 10 after 10 seconds? How far would he have gone? Wish you can do that in your head. You get 100 times 5, so 500. He would have gone 500 feet. All right. Next one. A particle is moving along the x-axis where x of t is the position of the particle at time t and is given by that formula. So I used x of t for position. Find the velocity and acceleration of the particle at any time. Okay. Now, once again, I realize that this one you could say, well, I could just multiply that out really fast. But I am going to ask you to work this one using the product rule in case those powers were higher. You remember how to do that. So let's find the velocity. So v of t, I'm going to do the product rule first, times the derivative of the second, power to the front, decrease the power by 1. Luckily, the inner derivatives are 1, so I don't need that. but I think of it certainly, plus the second times the derivative of the first is 1. Now let's do that factoring step. So t minus 3, I would have 2t minus 1 plus t minus 3. So what does that give me? The velocity is going to be t minus 3. And if I clean that up, 2t plus t would be 3. If I distributed, that'd be a negative 2 minus 3, and that would be minus 5. So there is our velocity at any time. So I have this right here. Perfect, perfect. And again, I know this almost seems silly to do it this way because I could certainly multiply that out and take the derivative very quickly. But once again, I'm just practicing in case I had higher powers. The acceleration would be first times the derivative of the second would be 3 plus the second times the derivative of the first is 1. So that's what? 3t minus, that's going to be a plus there. Sorry about that. I was about to say that doesn't look right. Plus, well, goodness gracious. Doing all sorts of bad things here. 3t minus 9 plus 3t minus 5. So that is 6t minus 14. There it is. Now, let's look at what the next question says. And we've kind of talked about this before. When would the particle be moving to the right? So here's what you've got to understand with these particle problems. Okay, the position, if I drew a number line, let me do it down here. If I drew a number line, so the position is 1, the position is 2. Of course, I can get into the negatives with my position, meaning I'm to the left there. So this particle, even though it's moving on the axis, I'm going to draw it above. You could figure out, of course, what the position was at 0. I could do that real fast just so I'm drawing an accurate picture. If I plugged in 0 for t, are you with me that I would start out at 9? So way over here, the particle starts here, and then it starts moving. Now, at this point, I don't know if it's going to move to the right or the left, but it's moving along the x-axis. It might change its mind, and then it might move this way a little bit, and then it might move back. You just don't know, so it's moving along here. So, in a sense, remember, when would the particle be moving to the right? That's saying, when would the particle be increasing the position, or when would the particle's position is increasing? Well, how do you tell if a function is increasing? Its derivative would have to be positive. So the particle would be moving to the right if v of t is greater than 0. And it would be moving left if v of t was less than 0. And of course, if it's 0, that means it stopped. So this particular question said, when would the particle be moving to the right? Well, here is our velocity. I need to figure out when the velocity is positive. So what I need to do is I need to do a sign analysis. Velocity equals 0 at t equals 3 and 5/3. So if I did a sign analysis on that, I have, now make sure you put those in the right order. 5/3 is less than 3. And notice I'm going to put 0 here. That's a reminder. It said that time's always greater than or equal to 0. We don't get into negative time. So I'm going to put that on my sign analysis so I remember when I write the answer not to go into the negatives. So what is that graph doing of velocity? Well, if I put a number like 1 into this velocity, I'd have a negative times a negative, which would be positive. I kind of know that it's going to do this. Again, you have the 0 I put in there because it was an endpoint, not because it was a 0. So I have a positive square root, squared with 2 zeros. So it's going to go plus minus plus. So the answer when is the velocity moving right? It's going to be moving right from 0 to 5/3 and 3 to infinity. And now you have to say since, because you know it's going to say justify. That's what these are. Those are your justifying. Since v of t is greater than 0. Since our velocity is positive, if you want to say it in words. Now, what is speed? Okay, remember velocity, there's a direction associated with it. So the velocity is, you could have a speed that is negative, meaning he's going to the left. So right here, if I found the speed v of like 2 or something, then you would get that to be negative. Well, so when that's negative, that means that's associated with a direction. And so with the speed, remember speed is the absolute value of velocity. So with speed, again, the absolute value of velocity. So I'm going to find v of 2. So when I find v of 2, and I can plug it in up there, notice that I have, I'm looking at this equation right here. 2 minus 3 is negative 1. And 3 times 2 is 6 times 1. And so that gives me negative 1. But remember that speed is the absolute value of velocity. So if I take the absolute value of that, the speed would be equal to 1. So the speed at t equals 2, I'll do it like this, is positive 1. So speed, of course, is always positive. So speed is the absolute value of velocity, and we get that. Sorry, I've been interrupted 10 times making this video, so I'm probably repeating myself. Right, kids? All right, so for the next one involves a calculator. So let's get a calculator for us. Okay, so this is a calculator example, and we have to remember the buttons we use in order to do that. So it says a particle is moving along a number line. The position of the particle for t going from 0 to 5 is given by that position formula. When is the particle moving to the left? So again, I tend to write my justification first. Particle is moving to the left when velocity is less than 0. So I want to find when the velocity is less than 0. But remember, I purposely put one on here that you do not know how to take the, well, you do. I'm trying to think. I'm making these videos. I kind of forget what you've learned and such. You have learned the derivative of e's, but nevertheless, even if you know how to find the derivative, why would you do that by hand? Why would you not do it with the calculator? So I want to remind you that you can do it on the calculator. So let's remember those steps. If you put in sine of x plus e to the, be careful, 0.1x. Oh, see, I typed in the wrong thing. 0.1, there it is, x plus 4. There's your, nope, there it is. Now that's your position. I don't really want to watch them graph position. So I'm going to go back to my equal sign and unhighlight that. I am going to double check that I am in radian mode, which I am, okay. So in y2, remember, how do you get the calculator to graph the derivative? You're going to hit Math 8, you want it to take the derivative of y1, so that's alpha trace, and you want to pick y1, and then x. So there it's going to graph the derivative. And I like to do I'm going to have to figure out where velocity is less than 0, so I like to put 0 in y3 personally. I like to do intersect versus root. Now, with my window, notice it says t going from 0 to 5. So why do I need to look anywhere but 0 to 5? There's no point in doing that. So I'm going to put my time to be 0 to 5. And then I'm trying to see when it's 0. So I could leave it negative 10 to 10. I could maybe zoom in a little bit on the axis, but let me just go from there and see what we have. Takes it a minute, but it's doing some hard work here. It's graphing the derivative. One thing while it's graphing, we can kind of see that we're going to have probably one interval there, because this is the graph of the velocity. So it just graphed the velocity. I'm looking to see when the velocity is negative. So I'm going to do second calc intersect. Second calc intersect. I'm going to put my cursor on this guy, get it close, and hit enter 3 times. Making sure I go to 3 decimal places. 1.689. And then I'm going to do second calc intersect again. Putting my cursor over here. If you hit the down arrow and go to the line, it goes a lot faster. Put enter 3 times. And I get 4.554. And that's when the particle would be moving to the left. All right, for the next one, it says find the velocity of the particle when its acceleration is 0. Now I want you to think about what you would do if you were doing that by hand. It said you would find the velocity of the particle when the acceleration is 0. So you'd have to figure out when the acceleration is 0, and then you would plug it into the velocity equation. Now let's remember a few things. And first of all, I probably should state somewhere, notice I said that v of t. I might write down that this is true. And if I'm talking about acceleration, just so my grader knows where I'm getting these things, is equal to, that doesn't have a prime, is equal to the second derivative. I probably would put that because they're going to be like, well, v, how do you know? So I'd probably put that as well. Okay, so find the velocity of the particle when the acceleration is 0. So here's what I'm going to figure out. I've got to find the acceleration equals 0 at some t value. I've got to find that. Once I find that, I'm going to plug that into the velocity, and that's going to be my answer. So again, let's see how we're going to do this on the calculator. We're not going to do this by hand. We're going to use the calculator. So we want the calculator to, now I don't want to really graph the velocity, I want to graph the acceleration. So I'm going to go back to my y equals screen. I'm going to unhighlight this. So I just remember y1 is position, y2 is velocity, and I'm going to ooch y3 down, and I'm going to do, for y3, I'm going to do the derivative of y2. So I get that the same way, alpha trace, I put in a 2 and the x there. So now I have the derivative of velocity, which is acceleration, And again, I'm trying to see 0, so I do like to put 0 in. But notice I keep those in there, and there's a reason why I keep this in here, and this is really cool. So here's what I'm going to do. I'm going to do the graph, let it figure it out for me. Takes it a minute. So there it is, graphing the acceleration. I need to see when the acceleration is equal to 0. So it's almost there. There it is. I feel like it's a sloth. But here it comes. Okay, finally. Then it's going to graph y2 or y4, whatever, the 0. So I'm going to hit second, calc, intersect. I need to find where that intersection is. This guy does not. Now, here's the cool thing that I want to show you. Yes, on my paper, I can write down 3.128 because I'm rounding to 3. So this would be 3.128. And then I'm going to find the velocity at 3.128. But with the calculator, remember this value is stored into x. And I want to make sure I use the whole value until you do another intersect or clear the memory or something. That value is stored into x. So I'm just going to go to my home screen. Remember how I kept y2 in there and y2 was the velocity? I'm going to hit alpha trace. I'm going to pull up y2 and say, you know what? Evaluate y2 at x and hit enter, and the calculator is going to do it for me. I don't have to type in all those numbers, and that is the beauty of, becoming kind of calculator savvy in what knowing the buttons to push. So I get negative 0.863. So this is my velocity when the acceleration is negative. All right, last one. Is the particle speeding up or slowing down at t equals 1? Justify your answer. We've done one like this, but again, we're going to use the calculator. What would you have to write down? What is it dependent upon? Remember, if they ask you about speeding up or slowing down, you have to look at two different things. You have to look at the velocity at 1, and you have to look at the acceleration at 1. You're going to use your calculator to get those values, and it's dependent on the signs. If the signs are the same, the particle is speeding up. If the signs are opposite, it is slowing down. But again, with the calculator, I don't have to type in equations. I just have to remember that I have velocity in y2 and acceleration in y3. So I'm going to evaluate the velocity at 1. I'm going to do these both together. And then I'm going to evaluate the acceleration. That was in y3 at 1. And what do you notice? You notice that, the signs of those things are opposite. So my particle is going to be slowing down. I just need to write down all those numbers. So I have 0.651. And I have negative 0.830. So since V of 1 and A of 1 have opposite signs, the particle is slowing down. But what most times people do wrong most of the time is they only get velocity and they say, oh, velocity is positive, so it's speeding up. Remember, speeding up or slowing down, you have to look at the velocity and the acceleration. All right, so use your calculator on some questions. Your homework is broken up into calculator and non-calculator part, so do the appropriate one, and peace out.